This is the final lesson for our module on 1.4, lesson 1.4c, and we're going to talk about the idea of slope and how it relates to a curve in particular. So the slope of a line, right? I mean, we're pretty confident in the idea of a slope of a line. We know that m is often the letter that's associated with slope. Some slopes are positive, so that would be rise over run. And some slopes are negative, but we know that the slope is consistent either way. So if you start at a point, the rise over run, that would get you to the next point, would be the same every single time. Okay, the slope is constant. Now with a curve, the slope is no longer constant. So let's look at a curve like this. If we try to determine the slope by doing the rise over run, the next time we do it, it changes. And then it becomes really small. And then if we turn the corner, the rise over run starts to go in the other direction. Now it's positive because it's climbing. But then it turns the corner again, and now the rise over run is going down. So the slope is always changing on a curve. So slope of a line, always constant. Slope of a curve, always changing, sometimes negative, sometimes turning a corner, sometimes positive, sometimes turning another corner, sometimes negative again. So the formula for the slope of a curve is the same formula that you were working with yesterday. And so we say that m, and then we'll put a curve down here, is equal. So this is not the m for a line, this is the m for a curve. It is the exact same formula as you've been working on for the instantaneous rate of change. So for this particular parabola, if we want to find the slope of the curve, then we're going to use the same formula we were working on. So we're going to do m, and I'm going to just write curve to show that it is a curve. The limit as h approaches 0 of f of x plus h minus f of x all over h. And so we'll substitute in, just like we were doing before, x plus h in parentheses into the equation, and then just x. So we will get parentheses x plus h in parentheses squared plus 2, and then minus the other equation, which is just x squared plus 2, all over h, with parentheses around the whole thing. So I'm going to need to FOIL my first set of terms, and I'll distribute the negative. So for my next step, I'm going to do FOIL and distributing at the same time. So I'll have x squared plus 2xh plus h squared plus 2, and then distributing my negative will give me negative x squared minus 2 all over h. And then we'll notice the cancellation that will happen. So x squared cancels x squared, 2 cancels 2, and then I'll have common denominators. So 2xh is left over the common denominator h, and h squared is left over the common denominator h. And those both reduce to 2x plus h, and then we'll substitute 0 into h, and we'll get the equation 2x. So this is the formula that will tell us the slope of the curve. So now let's go point by point. Let's say that this is the point -2 on the graph. Well, if I plug -2 into the formula I just got, it will turn out that the slope is -4. And so what that means is at that particular point, the slope value happens to be -4. But if I move to, say, this point right here, which might be -1, if I plug -1 into the equation for the slope, now I get -2. And so my slope is different, and it is now -2. And if I pick another point on the parabola, that's the point 0 right there. If I put 0 in, if I put 0 into the equation for 2x, that will give me 0. Now a 0 slope is a perfectly horizontal line. And if I continue moving along the parabola, if I move up to the next point, there's +1. If I plug that value in, I get 2. So the slope is 2. And if I keep moving up here, now that's the point 2. Plug it in, now the slope is 4. So now I have a slope of 4. So at every different point on the parabola, I would have a different slope value every single time. No matter what point I wanted to find, if I wanted to go all the way to the 13th point on the parabola, if I just plug 13 into the slope formula, then I will get 26. So that means at point 13 I have a very, very steep slope. Okay? It just gets steeper and steeper as we go, and we know parabolas do get steeper and steeper. Okay, so using the same parabola, now we're asked to write what's called a tangent line at x is 1. Well, let's focus on x is 1 right here. At the point x is 1, we have an x value equal to 1, but what's the y value? Well, I just have to plug it into the original equation to find the y value. So I'm going to plug that in right here to the original equation, 1 squared plus 2. And so I'm going to get 3 for my y value. So this is the point, x is 1, y is 3. We also know that the slope value, which we'd found previously on the previous example, the slope value is 2. So since I have a point value and the slope value, I'm going to write what's called a tangent line. Okay, the tangent line is an equation for a line which is y minus y1 equals m minus x1. We've worked with this equation before. And so we'll drop our x value in for x1, our y value in for y1, and our slope value. So the y value was 3, the slope value is 2, and the x value is 1. And this is called the equation for that tangent line that went right through that little point right there, right through x is 1. You could write a tangent line at any point. I could ask you to write the tangent line over here where x was -2. So if that's true, then we'd have to find out what y is, which we plug into the original equation, and y would turn out to be 6. And then we would use the slope from this previous table, and the slope was -4. And so we could write an equation for the tangent line there. So if we were going to try and do that, that would be y minus the y value of 6, the slope value of -4, and x minus -2. That would be the equation of that tangent line. So you could do an equation for a tangent line at any point around your curve. Pick the point, figure out the slope, and then you can write a tangent line. Okay, here's another graph. Find the slope of the curve. Now this is a picture of a hyperbola. The hyperbola has an asymptote down the x-axis and the y-axis, and the graph of the equation of the hyperbola looks like this. We want to find the slope of the curve. So the slope of a curve is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h, and that whole thing in parentheses. So I'm going to take x plus h and plug it into the equation. So I will have 1 over x plus h minus, and then f of x itself, which is just 1 over x, and the whole thing over h. Because this is a subtraction problem, I need to get common denominators. Remember, common denominators are for anything where there's an addition or a subtraction problem. So my common denominators would say I need to multiply x on the top, and I need to multiply x plus h on the top, on the bottom, top and bottom. All right, so my common denominator turns out to be x on top, and then x parentheses x plus h on the bottom. You don't have to distribute that. The distributing you'll do would be this negative right here, and that negative would distribute to both the x and the h. So that would give me plus, and as the negative distributes, I'll have negative x minus h. And then over the common denominator, x plus h. And this whole thing is still over the original h. All right, let's put our common denominators together. So x plus negative x minus h over the common denominator, x and x plus h. That whole thing over the original denominator, h. Now these two, x's and negative x, will cancel each other out. And then we have the problem of having two different denominators. So as we usually do with algebra here at this point, we're going to multiply by the reciprocal instead of having all this division. So I'm going to erase that, and I'm going to erase the h and the extra division, and instead I will multiply by the reciprocal 1 over h. And I'm going to use my eraser, and I'm going to get rid of these canceled out things too, just to help me clean it up a little bit. So look what I've got. I have a negative h left in the numerator, and I have a single h in the denominator. So what am I left with altogether? The limit as h approaches 0. The only thing left in the numerator is negative 1. And the only things left in the denominator are x and x plus h. Now I'm going to plug 0 in. And when I plug 0 in, I get negative 1 over x times x plus 0. So the final answer is negative 1 over x squared. So the formula negative 1 over x squared will tell me the slope of the curve at any point I pick along the curve. So I would have to pick a point, plug it into the original equation to find the y value, but plug it into the curve equation to find the slope. Or I could pick a different point, plug it into the original equation to find the y value, plug it into the curve equation to find the slope. So I'm going to actually do that the next question. Write a normal line at x equals -2. So let's picture where x equals -2 is. On this equation, x equals -2 happens to be sitting, about maybe right here or so. So my x value is -2. My y value would be come from plugging it into the original equation, so that's 1 over -2 or -1/2. My slope value comes from plugging it into the formula that we determined for the slope, which was -1 over x squared. So I will put -2 into that. -1 over parentheses, -2 squared. That's -1 over 4. That is called the slope value. So the line that goes through that curve right there, okay, the line formed by touching the curve at that point would be y minus the y value of -1/2, so there's a double negative, the slope value of -1/4, and then x minus -2. So I've got a double negative twice, so I'll turn that into a positive. And then I have a double negative also in the y value over here, so I'll turn that into a positive. Okay, this is called the equation of the tangent line. But we were asked for the normal line. So what is a normal line? A normal is the word that means perpendicular. So we've now found, although we found the tangent line, the perpendicular line will come through here and make a right angle. And it's super easy to switch this to perpendicular, because perpendicular means keep the point the same, because you're still going through the same point, but change the slope to the opposite reciprocal. Okay, perpendicular lines have opposite reciprocal slopes. And so my normal line would have everything about it the same as the tangent line, except the slope is now +4 instead. Everything else about it is the same. So the first one I did is what's called the tangent line. And the second one, with only the slope changed, is called the normal line. And that is formed by making a right angle on your drawing. Now, if the tangent line is horizontal, we can see it touches the graph right here at its little maximum, and it also, a horizontal, touches the line down here. If the tangent line is perfectly horizontal, this is the place where the slope of the curve is 0. Okay, the slope of the curve would work out to have a 0 value, and that would give you a horizontal tangent. And so if you're asked, does this equation have any horizontal tangents? You want to find the slope of the curve first, and then set it equal to 0. Set the slope of the curve equal to 0. Not plug 0 in, but set the slope of the curve equal to 0. All right, well, let's find the slope of our curve. The slope of the curve, m sub curve. Okay, the limit as h approaches 0. I'm going to use parentheses, and I'm going to put x plus h in first, cubed, minus 6 parentheses x plus h. So I just used parentheses to plug x plus h into the function first. Then I'm going to minus, I use parentheses again to use the original function. This whole thing should be over h, And now we're going to do some superfoil and some distributing. So the distributing would be the negative here, would also be the -6. And I'm going to superfoil the cube. So I already worked out the superfoil ahead of time. That'll be x cubed plus 3x squared h plus 3hx squared plus h cubed. That's the superfoil. Now I'll distribute the 6, minus 6x minus 6h. Now I'll distribute the negative, minus x cubed plus 6x. This whole thing is over h. So let's see what cancels out here. I have a positive x cubed at the beginning, and I find a negative x cubed farther back, so those things will cancel out. I have a negative 6x here, and I find a positive 6x, so those things cancel out. And nothing else cancels out, which means I'm ready for common denominator. So I will have 3x squared h over the common denominator h. I'll have 3hx squared over the common denominator h. I'll have h cubed over the common denominator h, and 6h over the common denominator h. So I had lots of terms left. Now I'm going to reduce h's where I can. So these two h's reduce, the last two h's reduce, and then I will have one h left there, and I'll have h squared left when I reduce the cube. So I'm left with 3x squared plus 3xh plus h squared minus 6. Now I'll take my 0 and put it in for the h values. So it's going to go here and here, and those will both be 0. When those are both 0, I can drop my limit notation, and I'll have 3x squared minus 6 is the only thing left. This is the slope of the curve. So the second part is to find out when this might ever be equal to 0. So now I'm going to continue, and I'm going to take 3x squared minus 6 and set it equal to 0. That's not too hard of a math problem. Add 6 to both sides. 3x squared equals 6. Divide both sides by 3. So x squared is 2. And then apply not just a square root, but a plus or minus square root on both sides. So this answers the question, does the original curve have any horizontal tangents? And the answer is yes. It has 2. It will have horizontal tangents at positive and negative square root 2. So the visual of that is a graph that looks like this, that will have a horizontal tangent skimming across the maximum right here, and another horizontal tangent skimming across the minimum. This one is where x is negative square root 2, and this is where x is positive square root 2. So it had 2 horizontal tangents. So to summarize the whole lesson from 1.4, A, B, and C, there are 5 ways that you can refer to the following formula. The following formula is used to find the slope of a curve, to find the rate of change, to find the instantaneous rate of change, to find the velocity, to find the instantaneous velocity. All of those phrasings refer you back to the same formula. Only if you had the word average in there, average rate, average velocity, average slope. The word average would lead you to f of b minus f of a over b minus a without any of the limits or h's or anything like that. But it's only the word average that clues you in to that. Otherwise, you're going to always use the limit definition for all 5 of those phrasings. So a lot of calculus is understanding what you're being asked for, because you can be asked for it in 5 different ways, but it's always the same kind of math that would be used to answer those questions. So this wraps up this week. So you'll work on this on your own, and then we'll kick off next week together answering any questions and troubleshooting anything that you've got on this lesson. Again, just a reminder, sign up for Friday help if you're having some struggles in this area or you want to go over your test. All right, have a good rest of your week, and just sneak it in there. Go Dodgers.